Suppose we have two power series that convert to f and g, respectively, on a common interval I. So then when we add or subtract two power series together, it converts to the sum or difference of the two functions f and g on the interval I. Now for any integer m greater than 0 and any real number b, if we multiply that with the series, say c sub n times x to the n, this converts to b times x to the m times f of x on the interval I. So note that this part here, this interval, this part of the power series convert to f of x. Convert to f of x on I. For any integer m greater than 0 and any real number b, the series from x of n times b to the x to the m to the n, that will convert to f of b of x to the m for all x, such that b of x to the m is in I. So note that here it seems like we have a composite function, right? The proof for this is provided in your book. The link I included it here. So take a look at the proof. What happened when we multiply the power series? When we multiply the power series, we have the so recall the power series, if they convert to f and g, they are two polynomials. So we technically multiply two polynomials and rewrite this as a power series. Okay, so the result of the power series, multiply two power series, is another power series, and it's convert on the product of two functions f and g on I. The series, the resulting series, is known as the Cauchy product of the series as n. Oh, this is supposed to say n equals 0. So change that, n equal to 0 to infinity. So let's take a look at the example. Suppose that you have two series. That is the sum from n equal 0 of a sub n to x to the n is a power series whose interval of conversion is -1 to 1. And suppose that n equals 0 to infinity of b sub n to the x of n to the b sub n times x to the n is a power series whose interval of conversion is -2 to 2. Well, let's find the interval of conversion of the series, of the sum of the series. This means the sum n equal to 0 to infinity to a sub n x to the n plus b sub n times x to the n convert in the interval of the common, that is -1 to 1. Okay. For b, well, this here, n equals 0 to infinity a sub n times 3 to the n times x to the n, we can rewritten as n equals 0 to infinity of a sub n times 3x to the n. We know that the series earlier convert to in the interval of -1 to 1, right? So then this meant that, so this then implies the series convert when -1 less than 3x less than 1 would mean -1/3 less than x less than 1/3. So that where the conversion of this series occurred. We will use the sum and difference of two series to find the power series representation for f of x. We kind of did it in the last example, right? In the last section, right? Where we rewrite this into a different series. Now, let's try this again. we have f of x equal 1 divided by x minus 2. We're gonna do this based on the fact that we know the geometric series f of x equal 1 over 1 minus x is the sum of n equals 0 to infinity of x to the n. I will go ahead and rewrite this f of x. F of x now equal 1 divided by x minus 2. This is the same as saying negative 1 over 2 minus x. So negative 1 factor out 2 x 1 minus x over 2. I can rewrite this as the sum at n equals 0 to infinity of negative 1 over 2 times x over 2 to the n. And this is the sum at n equals 0 to infinity of negative 1 times x to the n divided by 2 to the n plus 1. Okay. So here's x to the third. So f of x equal x to the third divided by x plus 2. This is x to the third divided by 2 times 1 plus x over 2 equal x to the third divided by 2, 1 minus negative x over 2. This is the sum at n equals 0 to infinity of x to the third over 2 times negative x over 2 to the n. So we have the sum at n equals 0 to infinity of negative 1 to the n times x to the n plus 3 divided by 2 to the n plus 1. Now we have a series. We want to find the function represented by this series, and then we determine the interval of convergence of the series. So this means I have the sum at n equals 0 to infinity of 2x to the n. So let's write out a couple terms of this series. This equals 1. Actually, I don't even need to do that because this is the geometric series, right? So this is 1 over 1 minus 2x. Okay. So since this is a geometric series, it converges when absolute value of 2x is less than 1. This means that it's converged in the interval of negative a half to a half. So what do I mean here by multiply the series 1 over x, 1 minus x equal the sum at n equal to 0 of x to the n by itself to construct a series for 1 over 1 minus x times 1 minus x. Let's start with the term of the series. So the sum at n equal to 0 to infinity x to the n, and we multiply it by itself. This is 1 plus x squared plus x to the third, so on and so forth, multiply it by itself. Okay, go ahead and multiply this out. When you do that, you get 1 plus x squared plus x to the third, so on and so forth, plus x squared plus x to the third plus x to the fourth, so on and so forth. And then we have add x to the third, x squared plus x to the third plus x to the fourth plus x to the sixth, so on and so forth. And we continue on multiply this out. When we do that and combine like term, we should get 1 plus 2x plus 3x squared plus 4x to the third plus so on and so forth. So this is the series for the product of the geometry series multiplied by itself. Let's talk about the term-by-term differentiation and integration of the power series. Suppose that the power series that's centered at A for some radius r greater than 0, and we have the function represented by the series, and we know that the function is converged when x minus a is less than r, and this means it's also differentiable for that interval. Since it is a differentiable function, we can find a pram. We can do that by taking integration of term by term of the series. And since we can take integration, since we can differentiate, we can also do integral, right? Now the uniqueness of power series, let the sum of n equals 0 to infinity of x sub n times x minus a to the n, and the sum of n equals 0 to infinity of d sub n times x minus a to the n are two convergent power series, so that the two series equal. If the two series is equal for all x in open interval containing a, then c sub n equal d sub n. What does it mean? That there's only one series that will make this happen. The proof is provided with the link, so go take a look at it. Now here we've been using geometric series to find the power series representation for a function, right? But what happens when we can't use in geometric series? What we do? Well, find the power series representation for ln of 1 minus x and its radius of convergence. Let's talk about the domain of this function for a minute. The domain of this function x is less than 1, right? So accept at x equal to 1, the derivative of the function is 1 over 1 minus x. So accept the derivative of this function is 1 over 1 minus x. We miss a negative here. So let's say if I go ahead and start with negative ln of 1 minus x. This is the integral of 1 over x, 1 minus x dx. Well, 1 minus x dx, well, that is a geometric series, right? Well, the term of the geometric series, then it'd be 1 plus x squared plus so on and so forth dx. Well, then I can take the integral. Then I have x plus 1/2 x squared plus 1/3 x to the third, so on and so forth. So similarly, this is the sum at n equal to 0 to infinity of x to the n divided by n plus c. But the function that we have in question was ln of 1 minus x, not negative of ln of 1 minus x. So to solve that problem, we multiply both sides by negative. Okay. And we also need to figure out what happened at c. Okay, to determine value of c, let's start with x equal to 0. When x equal to 0, negative ln of 1 minus 0 is equal to 0, equal to c. Okay, this meant c equal to 0. This function is converged, same as the original series, and it have the radius of 1. Now let's multiply with the whole thing by negative 1. So ln of 1 minus x is the sum of the sum of n from 0 to infinity of x to the n divided by n, where absolute value of x is less than 1. And here we have the convergence. So this converts when absolute value of x is less than 1. And it have the radius r is equal to 1. When we have the whole function here with the series, so let's identify this function. What is this function that have that series? Let's go ahead and differentiate a few terms of this series. Then f prime of x here equal 1 minus x squared plus x to the 4 minus x to the 6 so on and so forth. So look like f prime of x is a geometric series that look like this, that 1 minus negative x squared, or that is 1 over 1 plus x squared. Okay. Well, if I go ahead and integrate f prime of x, do I get? I will get tangent inverse of x plus a constant. Now I need to figure out the constant. When x equal to 0, f of x is equal to 0. This means, so then c is equal to 0. Okay, so here we can see that, well, f of x equal to 1 minus x squared plus x squared minus x to the 6, so on and so forth. This is the representation of tangent inverse of x, and it's converged from negative 1 to 1.